I just took the September SAT a week early. This is what happened. I was supposed to take the August SAT in the Moscone Center in San Francisco, but so many people had Wi-Fi issues that like more than half of us couldn't even take the test. Going into the test, I kind of thought that it was going to be the same as like the August SAT. It was going to have similar question types, but like some of the questions were really different. So today I'm going to go over some of the questions that I saw. These question types have a really high chance of being on your test next week, so I really recommend locking in on these concepts.
If you guys are curious about score prediction, probably going to get a 790 math. I'm not too sure about English though, but we'll be going over the question that I think I got wrong today.
Alright, so before I show you the questions, I want to preface that every single question here was on my SAT, but I'm not saying the exact question, otherwise I might get my score canceled. So every question's topic was on my SAT, and I'm going to cover it in full using the Michael strategy. And what is that? I'm going to show you. So first, let's go over some of the contents. We're going to start easy so that you guys can get into a rhythm, because me personally, when I used to be like you guys, I used to be so locked out, and I used to be getting like 1400s, and I would watch these like Desmos guides, and they would be using the hardest problems,
And I would just immediately click off and start doom scrolling.
So we're gonna start pretty easy, and then we're gonna get into some of the harder stuff once you get your Desmos knowledge warmed up. So one thing I wish I did when I first started out doing the SAT was focusing on one unit at a time and spamming practice problems for that. We're gonna be spamming percent questions. For circles, we're gonna be spamming circle questions. This way you get it ingrained into your mind how to do these types of problems, and you're not just like sporadically doing it. But yeah, let's get started. So for the first question, it's giving us 3 points. So anytime I see points, I'm just gonna use the table feature on Desmos, and I'm just gonna plug it in. So -9, 5, -10, -8, and then -6, -40. And then from here, we're gonna use something called regression, which is you just click this button, and then it gives you a linear regression, a quadratic, all this. But as you notice, the question says quadratic, so you would click quadratic. And then now from here, it's asking for a function notation. So you would just replace the y with f of x equals -3x squared minus 60x minus 292. And then now you can just write f of 9 minus f of 11, and you get 240, which is our answer. So this is actually a really simple way to use regression for algebra. And let's do a similar question next, so we really get it ingrained into our minds. So for this next question, you guys can pause if you want to solve it. I highly recommend you do, so you can use that knowledge. But the way I would do it here is I would use the table feature again, and 3, -4. And as you notice, they only give us 2 points. And a quadratic, you always need 3 points for a quadratic. Like, if I do this, it's going to give us some weird quadratic, right? And I already know this is wrong. Why? Because a quadratic is written like this. There's 3 constants you have to solve for. And Desmos, when you use regression, if you give it 2 points, it can't solve for 3 constants. So you need a 3rd point. So how do we do this? So the first thing I would do is I would put this into a vertex form. So what is vertex form? Vertex form is y equals a x minus h squared plus k. So what I can do is I can link the points from this table into this form. So what I do is I would do y1 and the next one, and I would add regression. So now it's telling me that a is -0.15, but h should be the x coordinate, right? So it should be 9 and then -13. So now I'm getting a is 0.25. So let's go back, and now let's plug it into our function notation, right? So I do f of x equals 0.25 x minus 9 squared minus 13. And then I would do g of x equals 4 f of x minus 2. And then I would do g of 0 minus f of 0. And I would get our answer 61.75. Okay, let's keep it pushing. So percents is one of the most feared topics on the SAT, but I'm going to show you that percents are actually one of the easiest concepts on the SAT, and it's just 3 points every time. So I'm actually going to ungatekeep the method that I've been telling everyone. So
hey, don't be surprised when I switch up on you guys and I start selling a course.
okay, so first things first, we're going to read the question, and it's saying that 53% of A equals 27% of B. What I'm going to do is I'm going to do a system of equations regression. So what you can do is you can do a bracket and then another bracket. So what I'm basically telling Desmos is that whatever's in here is equal to the thing in here. So A is equal to 16. Why? Because A and 16. Do you guys see it? And then if I wanted to add another thing, because it is a system of equations, I would do like B is equal to 68. And then you see? So let's do some practice. Let's say, what do we do if we wanted C to be equal to 50? I would do like C 50, and then, you know? So now let's apply that to this question. So it's saying that 53% of A is equal to, so anytime you see equal to, you're going to move from this box to this box, okay? So this box now is going to say 27% of B, and so we're going to write a comma, A equals, so now we're going to get this box, 34% of C, okay? And now it's saying what percent of B, so W, because like what, W percent of B is equal to C. And now it's going to give us our answer, 149.83352. But of course, that's not our right answer because it's saying round our answer to the nearest tenth. It's going to be 149.8. So I hope you guys understand why I did this. Blank percent of B is equal to C. So W percent of B is equal to C. And what is W? Is 149.8. And that's our answer. Okay? So now that you understand this concept, I just ungatekeep the method for everyone. Now it's your turn to do this one, okay? So I'm going to give you like 2 seconds to do it. Okay, now. So this one's, we're going to have to assign our own variable. So we're going to say soccer players is equal to A, basketball players is equal to B, and tennis players is equal to C. So from here, we're going to do the same thing. System of equations regression. Okay? We're going to say number of soccer players was, so was is basically equals, because like A is 16, A equals 16, A was 16, A equals 16, okay? So the number of soccer players, which is A, was 2,000% of the number of tennis players. Next question, next equation. The number of basketball players, which is B, was 75% of the number of soccer players, which is A. Okay, and then now, if there are 1,960 soccer players, so what we can do is we can say A is equal to 1,960. What was the sum of the number of basketball and tennis players surveyed? So basketball is B, and tennis is C. So B plus C is 1,568, and boom, there's our answer. All right, we just did 2 equations, 2 extremely hard percentage equations in like the blink of an eye. So now it's your turn. You have to do this without my help, okay? So pause the video, do it without my help. It should be pretty easy. You just did 2 practice problems, but anyway, I'm gonna get started. So I'm gonna first set up this. I'm gonna say 68% of H is equal to 92% of J, and J is equal to 34% of K, comma, W again, what percent of K is equal to H? And W is 46, okay? 46%. I'm just saying W is like a placeholder. It's not actually, there's no W. It's just like blank percent of K is equal to H, you know? Okay, so you've officially graduated from circles, or from percentages. As you can see, that was light work. Time to move on to circles. So I don't know why everyone's also scared of circles. Like, Loki. Let's just show you. So first we're going to type out the equation. We're going to draw out the circle. Equals to S plus 3. So then it says that 9,8 is on the circle. So let's just write S. So we just have to move it until the red line touches the blue, okay? It's low-key. Okay, wait, let me do this. 150, so now, oh, keep going. And stop. Oh, wait, more? Bruh. Oh, stop. And there you go, that's our answer, 97. Why? Because when S is equal to 97, then it touches 9,8. What happens when we go over 97? Oh, it doesn't touch it anymore. You see? It doesn't touch it, so we gotta go back. Oh, that's too much, it doesn't touch anymore. Okay, yeah, you get the point. Okay, so for this next question, it's talking about endpoints. So you need to know what an endpoint is. So let's just graph out a demonstration circle like this. So can you tell me where the endpoints are? So an example of an endpoint would be like right here, or like right here, right? Or like here and here. So for this question, it's giving you the endpoints and then it's giving you the center of the circle. So what can we do with it? So if I'm given that the endpoints of this example circle are -1 and 1, what is the center? How can we find the center given the endpoints? Well, we can do something called the midpoint formula, where you just take the 2 points and then you divide by 2. So it's 0, right? The center is 0. Okay, so in this equation, the center of the circle is -7. Why? Because the equation of a circle is x minus h squared plus y minus k squared equals r squared. It's not x plus h. That's not right. It's x minus h. So if we know the center is -7, and you know that it's equal to -15 plus a over 2, then you get a is equal to 1. And that's our answer. So no scratch paper needed, just done all on Desmos. Okay, so this next section is all about scale factor, which is super important. So let's just dive in on how to do this. So anytime you see scale factor, it's a super easy regression, okay? So let me show you what I mean. So the relationship between two similar objects, like a cone or like a rectangle, it's always going to be a scale factor. So like, let's say there's a side length that's 10 inches and then another length that's 36 inches, right? So the scale factor would be 3.6, right? So in this case, the volume is 125 and then the other volume is 216. So would the scale factor be what? What would it be? It would be 216 over 125, right? But that's wrong, actually. The way you would do it instead is, because it's talking about volume and not like a side length, volumes are cubed. So you would have to do the cube root of 216 over the cube root of 125. So this gives us the actual scale factor, which is 1.2, okay? And then now we need to relate this to area. So what we can do here is use a regression. So an area is not cubed, right? Because an area is squared. So what you would do is, for the smaller one, it's 25. So then the bigger one, we don't know. Let's just call it W for like what? What is it? What is it? So now it returns to us W is equal to 36. So this is super easy. Our answer is going to be B. So this is how you solve these tricky scale factor questions in like 5 seconds, okay? Okay, so for the next question, I'm going to let you guys do this. It's exactly the same concept. Let me just give you guys hints. Volume, you're going to use cube root, and then for area, it's going to be square root, and then for side length, it's not going to be any root when you're doing the regression, okay? So remember, let me just go back. 216 is to 125 as W is to 25, you know? Like, the cube root of 216 is to the cube root of 125 as the square root of W is equal to the square root of 25. Okay, so for this question, it's another scale factor question, and we can easily use regression for this. So what I mean is, we're given that this is a cube, right? And then the edge length of A is, so we move on to the next bracket, 4 over 27th the edge length of B, okay? And now it's saying the surface area of B. So if you don't know what the surface area is, that's fine. It's in your reference sheet, but it's going to be 6A squared, or 6 edge length squared. So for this one, the surface area of cube B, so we're going to do 6B squared, is equal, so we're going to move on to the next box and add a comma, K times the surface area, which is 6A squared, of cube A. So what is the value of K? And as you can see here, it gives us K is equal to 45.5625. And how do we represent that as a fraction? 729 over 16. So our answer is going to be C. Okay? This is why I love scale factor. You just use regression and you get it. Okay, so for this question, it actually looks really, really complicated. But trust me, Desmos is going to save the day. So first, it says that 6x plus 17x squared plus 7. And if you're wondering why I'm using x1, it's so that whenever you're using regression, you always have to set it equal to x1. So you can do 3x1 squared plus a 2 squared plus b. And now, as you can see, oh, it gives us the value of a, which is 7, right? But this is only when x1 is equal to 1. Okay, so now you're going to tell Desmos, hey, I want it to be true for every value. So what you can do is you can assign x1 to be a number other than 1. So you can tell x1 can be any value. Now it's saying that a is equal to 7 and b is equal to 1, okay? So there we have 7 and 1, which are the integer values, right? But now it's asking for non-integer values. So I'm just going to rewrite it, but this time with C and D. And this time, how do I tell it that I want non-integers? So basically integers are like 1, 2, 3, 4, 5, 6, 7. And then non-integers are like 4.1, 1.02, and stuff like that. So what we can basically tell it is use the mod function. So what the mod function does, it's highly complicated, but just trust me, bro. What the mod function is basically saying is that when you divide c by 1, will there be a remainder? You're basically saying, hey, when you divide c by 1, the remainder is 0, right? So what you want to do is you want to say that the remainder is greater than 0. So we can be like, hey, when you divide c by 1, the remainder is greater than 0, which means it's not an integer. So this is a great way to find out non-integers, because as you can see, the value of c has a remainder greater than 0, okay? So the value of a plus c is 8.5, and that's our answer, okay? Okay, so for this next question, you need to understand that when two values have the same slope but different y-intercept, they have no solution. So what I mean by this is, say, let's just do 5x plus 2, and then let's do another one with the same slope but with a different y-intercept. So 5x plus 5. And as you can see, there's no solution. They never intersect. So how can we apply this to this equation? So what we can do is we can ignore the y-intercepts, right? We already know it's going to be different because 30... If you expand this one, it's going to be 3xk plus 39. And this one is 48 over 17x plus 36. So we already know that the y-intercepts are going to be different, right? 39 is not 36. So let's just delete this. And now, like I said before, the slope needs to be exactly the same. So how can we do this? So we can say 3k x1 is equal to 48 over 17 x1. And now it gives us the value of k, which is 0.94, okay? And then we convert this to a fraction, it's 16 over 17. So the value of k is 16 over 17, okay? Next question. Okay, so this question is basically exactly the same, okay? And don't get confused when it says, oh, what cannot be n plus k? Because watch. So as we mentioned before, when something has no solution, it has the same slope, right? So what's the slope of this one? It's negative 7x. So the slope is negative 7. So what do we plug into n to make it the same slope? All right, we're gonna whip out the regression for this one. Okay, this question is basically like the last one. So watch this. So like I said, two equations have no solution when they have the same slope but different y-intercept. Okay, so what's the slope of the first one? It's negative 7x. So the slope is negative 7. And then the next one is nx. So what do we plug into n to make the slope the same? The answer is, you know what? Matter of fact, we're whipping out regression. So we can do nx1. So now we get n equals negative 7. Okay, so now let's just plug it in, right? We would get negative 7x minus 7k is equal to negative 7x plus 2n, right? So what here would make it not infinite solutions? What value here would make the two y-intercepts the same? Well, let's just whip out regression again. Negative 7k equals 2 times negative 7, and we get k is 2. So what's k plus n? Negative 5. So that's our answer. So let me just go over this again, okay? So the reason why we wanted to see which value would make it the same is because it's asking for what cannot be the value of n plus k, right? Because otherwise that would make it have solutions, right? So pretty tricky question, but let's move on to the next question. So I love these questions because what you can do is you can just type out the question bar for bar, and then as you can see, we're getting like a freaking error, which is kind of annoying, but all you have to do is do this, equals 0, and boom, Now you got it. So now what we do is a game of guess and check. So what we can do is just type in the rest of them. I'm going to speed this up. And basically what we're looking for is which one of these has the same graph as the red one. So as you know, this was the OG graph, and we're asking which graph is equivalent to this one. Is it this one? No, because it doesn't line up. Is it this one? No, it doesn't line up. Is it the next one? Oh, it is. Oh, well, okay, next. So the answer is C, because it matches up with the graph perfectly. I'm not even going to check D, but you get the point. So this next question was on my SAT. I was so excited because I've been practicing this. Okay, so for this question, it has two lines that are perpendicular to each other. So perpendicular means that the two lines have negative reciprocal slopes of each other. So let's just make a table for line N, because it tells us that line N passes through 5 and 245. And then it also passes through 2 and 98 because they intersect at that point, right? So let's add the regression, and now it tells us that the slope is 49x, right? So the negative reciprocal of this slope is negative 1 over 49, right? So now let's make a table for line M, because what we just was line N. So line M goes through 298 because they intersect at that point. And then now, if we're given the slope, what can we do here? So we know that the slope is equal to the rise over the run, right? So let's just make this even simpler. Let's do this, 1 over 49, and let's do negative 1 over 49, right? Because that's the same thing. So every time it rises negative 1, so that's the y-coordinate, equals delta y over delta x. So every time it rises negative 1, so 97, it's going to run 49, which means the x is going to add by 49. So this becomes 51. And now if we graph it, it's going to give us this equation, okay? So let's plot it, and now it's right here. So now it's asking, what will it be when the y-coordinate is 96? So what we can do is do y equals 96, and we need to see, where do these two meet? Okay, where do these two meet? They meet right here. So the answer is 100, okay? Next question. So this question looks really, really hard, and I guarantee you this was on my SAT. I low-key got stumped for 30 seconds, and then I realized how to do it. So f of x is equal to h minus 7x over x plus 14. So what we can do is it gives us a table of values, right? So let's just use a random one. Let's use 5.25. So this is f of x. So let's just plug in 5.25. And then we can say h minus 7 times negative 2, y, because we're plugging in negative 2, over negative 2 plus 14. And then boom, h is 49. It's so simple, right? So I got that in 30 seconds, and I'm pretty sure this is going to be on September SAT, okay? So next question. Oh, physics, let's go. Okay, so physics, everyone always gets so confused, but it's probably because, I don't blame you guys, because you guys have not taken AP Physics yet, but as a person who took AP Physics 1, this is the easiest thing. Okay, so first let's set up the table, right? So it's saying that the object was launched from a height of 25 feet. So let's just assume that the x-coordinate is time, right? And the y-coordinate is the height. So just pretend so let's just plot down the points. So it started at t equals 0, which is time is 0, from a height of 25. And then it reached a maximum height of 100 feet. So 100, 5 seconds after. So if you were to do a regression right now, it'd be wrong. And the reason why, I'm going to teach you a hack. So when you throw a ball, it's always going to fall down, right? And if you guys are familiar with quadratics, the y-coordinate is going to be the same, right? So what you can do is, you know that at 10 seconds, this is going to go back to 25. And there, that looks better. So now you have a function, and you can do f of x equals negative 3x squared plus 30x plus 25. And you can say, what is f of 9? Because the x-coordinate is the time, remember? And now your answer is 52, okay? So our next question is going to be similar. It's actually exactly the same, just with different wording. So let's make a table, and I'm gonna give you some time to do it. So go ahead. So what do we know from last time? We know that time is the x-coordinate. So at 0 seconds, it is at 0 feet. It's basically at ground level. And then after 12 seconds, it reaches a height of 576 feet. And then as you know, in double the time of the vertex, which is 12,576, it's going to go back to its original point, right? 0. If this was like 25, this would also be 25, right? It's just where it started from, right? So this would be 0, 0, okay. And now let's make a quadratic regression. So let's just copy this, equals negative 4x squared plus 96x. And then now it's asking for 16 seconds after being launched, how high is it? So you can do f of 16, and your answer is 512, okay? Simple. Last question, so easy. You guys already done 2 practice problems. You guys got this, okay? So you guys get 2 seconds to do it. Okay, so it starts when time is 0, it starts at 10 feet above, okay? So now it reaches its maximum height of 1,034 feet, 8 seconds. So what do we do over here? Big question, big question. Well, we multiply the vertex value by 2, and then we write down our original height, so which is 10. And then we do a regression. So we get y equals negative 16x squared plus 256x plus 10. And then we do, f of x. And then we do f of 10 because it's asking 10 seconds after its launch, and I already get, all right? Oh my gosh. And now we get our answer, 970, okay? All right, guys, that's going to be the end of the video. That's everything that I saw in my September SAT. I'm manifesting you guys to get that 800 math because it's pretty easy, bro. So thank you guys so much for the comments. I love reading you guys' comments. It's always hella funny. So keep leaving those. And yeah, subscribe if you guys enjoyed. Bye.